We're going to do part 1 of the HTTP servers lecture now. This lecture could probably be 2 hours if we really tried, but I've found that if we just tackle a little bit of it today, just a little bit before the kind of full lecture on it tomorrow, that it just takes the edge off a little bit, which is really useful. This is one of the most, two things to preface this lecture. This is one of the most important lectures, not today specifically, probably more tomorrow. One of the most important lectures in the course, but also it's kind of what I consider to be the end of the, the first hard part of the course. This course is 9 weeks, right? With Flex Week. Week 10's a bit of relaxing, a bit of chill, a couple of bonus lectures, the exam. So we really have 8 weeks of lectures if you think about it. And, tomorrow's halfway through the meaningful lectures in the course. And this course has a lot of the harder content at the start because we want to give you the tools to do stuff with. So I just want to, point out that there's definitely going to be a contingent of students who at this point are certainly feeling like their brain has a lot thrown at it. And to those people, well, all I can comfort you with is that we are toward the end of that, so to speak. And this is where I feel like we start to get to that point. So this lecture on HTTP servers, web servers, products built on websites are a fundamental part. Let me take a step. Products built on the web are a fundamental part of how software is distributed and used today. The majority of you will go and work on software that is distributed on the internet, or specifically through web browsers. Super important. And web servers, the things that power a lot of these websites or web apps you use, the things that sit, in Amazon or Google or Microsoft, centers with all, churning through all your data every time, you upload a YouTube video. All these kinds of servers are a fundamental part of how web-based applications exist. This lecture we're going to talk about networks in general, a bit of just high-level touching on computers and networks. We're going to talk about a particular type of web server that's really easy to build in JavaScript. We're going to talk about APIs, and we're going to talk about CRUD, which is a certain way of building APIs. Most of the APIs and stuff will happen tomorrow, but let's start going through it. So, firstly, networks. This is a very old slide. I've had this in for a few years now, and I think it's very important to understand the difference between these three words. Networks, internet, and the web. I think it makes it easier to talk about. I think if you can talk about something, then life is substantially more manageable. And a network is simply a group of interconnected computers that can communicate. The way I like to think about this is that most of you are sitting at home right now, or you if you're not, you will at some point today, and you're connected to your router or your Wi-Fi at home, and that router or Wi-Fi can disconnect from the internet, but you can actually still talk to all the computers within your house if you wanted to, right? Like everyone in your family, if you're all connected to the router, you could send things to each other if you tried certain ways, a little bit nerdy ways. You wouldn't need the internet. You wouldn't need Telstra or whoever. And that's a network. It's a group of computers that can talk to each other. That's it. Doesn't need the internet. The internet, though, is a global infrastructure of networked computers around the world. Right, so the very first networks were computers in a room, then maybe computers at a university, and then universities started connecting their computers together, and eventually, this network got big enough and someone was like, let's call it the internet. The internetwork, I don't know, is that what it stands for? Never thought about it before. And then you have the web, which is a really interesting subset of the internet, which is specifically when you use the internet via a web browser, basically. So if you open Google Chrome, Safari, Firefox, anything like that, you are using the World Wide Web. That's why you see www, sometimes they call it the web. And it's a certain way of communicating over the web. There are lots of other ways of communicating over the internet that aren't the web, which we kind of chat about in a sec. But if you do want to go learn more about networks, because this is about as deep as we're going to get, go study Comp 3331. It's networks, and I didn't study it, so networks and something. What's it called? Computer networks and applications. Cool. On the internet, or in computers in general, it doesn't need to be on the internet, but let's just imagine it's on the internet. We need certain ways to chat that are based on protocols, and we call these network protocols. They are a structure so that different computers know how to talk. So when your computer sends a message to your friend's computer, how do they speak on the same language? And it's like, you do this all the time as a human, whether it's like clapping, waving, handshakes. You know, you go to meet someone, you wave goodbye so they know you're leaving. You say goodbye so they know you're leaving. You do this when you pick up the phone. You pick up the phone and you don't know, you say, hi, you know, this is Hayden. How can I help you? That's a form of a protocol. It's a standard operating procedure that everyone kind of understands exists, and therefore people can talk. Computers do the same, and there are different protocols for different ways that we communicate over the internet. And there are lots of them, and they're really nerdy, and they're very technical, some of them, and you know, most of you have heard of some, and maybe not a lot of others. But you know, maybe some I'll draw your attention to are, if you've kind of seen any, you know, you might have seen IMAP or SMTP if you ever played around with your email. Some of you might have heard of FTP, a way of transferring files, a few other things. A few of you would have heard of many of these, and you'll know exactly what they are. But the point of articulating here is that HTTP, which you would have heard about when you copy and paste a URL, is a particular way, it's a particular protocol of how people communicate on the internet. And it was designed to help people communicate via web browsers. That's why the URL, literally like up the top of this page, says HTTP there. It's just all based on the web browser. So that's why, you know, whilst there are maybe different ways of SSH is another protocol. We forgot SSH isn't on that list. So whenever you SSH into something, or SFTP or something to do with VS Code, they're all different ways of using the internet that have nothing to do with HTTP and web browsers. And a lot of what we're focusing on today is not on any of these other things. They're on HTTP or web browsers. So HTTP stands for Hypertext Transfer Protocol. It is a protocol for essentially sending and receiving documents via the web browser. So if you think about a web page, you know, think about like this. When I Google, you know, Roger Federer, tennis player, recently retired, right? What do I get here? I get a page. I get what you call a resource. It's some kind of material. HTTP is just the standard that governs how people transfer these materials together. This slide deck's material, you know, my UNSW is another piece of material. And fundamentally, all that's happening when you paste a URL, you type in a URL and you access something, is that you on your computer, on your web browser that we call a client, are sending a message to a web server somewhere, maybe in Sydney, maybe in Melbourne, maybe in Singapore, maybe in Oregon, doesn't matter, somewhere around the world, and you are asking for a resource, you're asking for some kind of document information, and you get it back. And that's how most of your day is probably powered, right? You load up YouTube loads, and then you do something, and you're asking for more video, and it's sending you more video. It's all more content, all happening through the web browser. So web browsers at its core are applications that help request and receive HTTP messages, which is how which is a protocol that governs how we get documents and stuff. We can make our own web server that operates using the HTTP protocol using a popular NPM library called Express Server. Express Server is a very simple server that has been downloaded 25 million times a week. It's a lot, right? We've been talking about this a bit. And you'll see from its website that it allows us to get some very simple code here. I'm going to have to modify this code very slightly. Nope. I will have to modify it just very slightly to work with our different syntax. But there's actually some code examples, sorry. Look at the lecture code examples, even though you can figure things out pretty quickly by Google. But this is all it is. It's a simple file. I import Express from Express. You've done some imports already. I create a new web server here. This is like creating an instance, a version of a web server, right? Bringing it to life, and it's called app for application server. I pick a port that it's going to run on. We'll come back to ports. This isn't a networking course, so we gloss over it pretty lightly. I add some magic here, which isn't that important. And then what I do is I I actually define what the web server can do. And we'll unpack some of these lines together. But in this particular case here, this is me saying that when someone accesses my web server at address / I want to send back to them hello world. And then this last line here is saying this web server is going to like bring it to life and make it listen for people trying to talk to it. So if we go back to this slide here, you're creating the thing on the right, the one like right there. And you're listening for people like you and your friends to talk to it. So that's what's really being said here. It's like, okay, for this new application server I've made, listen for people to talk to me on this port. So if we open up the example here, I'll make this smaller again. And I run it, npm run ts node source 4.2 express basic. Right? What you see is that it starts saying listening on port 3000. Now what this actually means, which is a little bit interesting, is if I right click on VLab, I go to Internet and I go to Chromium Web Browser. And I open this up. What is happening on the left here is a bit unlike the programs you've been running to date. The programs you've been running to date, they tend to just run and then stop. You run them, they start, they stop. This web server is kind of running inside like a while true loop. It's like running forever in a way. And what it's telling me is that if I go and access the web server via the web browser, it will listen to my requests. And because I'm running the web server like on my computer here, there's a very particular like name which is quite interesting, which is localhost. And localhost is this weird, it's kind of like a website name, but it means your computer. And what I can do here is I can say I'm going to access my computer, or in this case VLab, doesn't matter, on port 3000, and there you go, and I'm going to get hello world. Now the things to pay attention to here are that it's always localhost, because it's always running on your computer. You're developing something, so it's always localhost. Port 3000, computers on networks are made up of a whole bunch of little pigeonholes, a bunch of like spaces that they can all run in parallel. It can be pretty much any 4-digit number or 5-digit number, so I could do 9999. I could stop my server with Control-C and I could restart it again. And now if I load up that page, it won't work anymore. But if I load it up on 9999, it will work, you know, like that. So, you know, it's happening there. And the interesting thing again is that, so this is all set up the top. And everything down here is running the server. But this is the actual kind of content of the server itself. And what you can do is you can go make a whole bunch of these if you want, and you can put different URLs here like hey, and you can change what they do. And in this case, you know, if someone accesses /hey, I'm going to have it say hey, and if someone accesses /by/by, I'm going to have it say bye. You know, it can be anything you want. They're all just strings. They can kind of be anything. And if I restart my server, you'll see that now, if I come here and I access the normal one, I get hello world. If I access hey, I get hey. And if I access by/by, I get bye. So we've been able to just write a very simple program and run it that can deal with like lots of different use cases, you know, which is kind of cool. It's kind of cute. It's a good bedrock for what we want to do next. Usually what I like to do here, and we'll kind of talk through that again, and I don't want to get into the API stuff today. I just want to kind of run the Express server and talk a little bit about ports and networking. The thing about networking and ports that's very interesting is that on your computer right now, there's a whole bunch of ports that are available for kind of like development and fun. They're not low ports, right? So like if I go like available ports, HTTP or something, there's usually like, there's kind of like this list of ports that ports don't think of them physically either. I know some students can get lost. They're like virtual, like you get this, right? Like on your computer, you have like maybe 3 USB ports, USB-C or something. And you can you can do 3 things at once. And once you do more than those 3 things, you just can't do any more, you know? ports are very similar in a networking sense on your computer, where, say, your computer, localhost, has a whole bunch of ports, right? It has like, I don't know, it's like tens of thousands. It's a lot. And some of them are used for very specific things, and you can see them here. You don't need to worry too much about these. These are used for very specific use cases. And then above a certain point, no one really uses them for anything in particular, which I don't think is listed here. It's like 4,000 or something. Someone would know off the top of their head. It's like, I don't know, 1,000 to 1,028 or something. Can't remember. I don't know. Minimum network port number. It's not really going to tell me. There's a number. It's obvious. I should know it, but I don't off the top of my head. It's like around 1,000, but basically, like, if you think of 3,000 as your standard minimum, I mean, I've never really worked in an environment where anyone's picked a number lower than 3,000. It's kind of like assume that, let's just call it 3,000. Everything above that is essentially just free reign up till about 65,000 or something like that. So you can pick a random number, right? I wouldn't pick 1,531. It's a bit low, as I said, stick above 3,000. But you could pick, you could pick 3, 4, 5, 4, 3, like that. And you could go and run a server on that. And what this allows you to do is essentially allows you to run applications that listen on a network of a computer. Because if you imagine your computer for a second, your computer is honestly just like this. Like, if you think of your computer's network, its interaction, as people talk to it, it's just this grid of ports. And there are a lot, like, software can run on each of these ports, and they'll all be busy with something. One of them might be used for this, one of them might be used for this. So when you develop, you just pick a random port and you just kind of work on it. The reason this is important is because when it comes to VLab, VLab's a little bit weird because VLab is actually a physical server sitting in, actually it's not sitting inside, I don't know where it is anymore. Maybe it's on AWS finally, but it's an actual server. And believe it or not, like, even though it feels like this very abstract thing, what's actually happening on VLab, you know how on your computer you can have like a couple of user accounts. Like, you could have your account and your sister's account or something. And you can both kind of log in into different accounts. And they're kind of separate, but they're still maybe running on the same machine. A lot of like big user servers like the one CSE has, they can have one computer that can like have many people logged in at the same time in like little environments. And they're all sharing the same RAM and the same hard drive and, all this kind of stuff. CSE does a similar thing, except the way CSE is set up is they actually have like about 8 of these computers. And you can actually see this very easily if you have a look at your terminal on VLab. For instance, this one says VX3. And when you connect to VLab through Tiger VNC or something, right? Let's say you use VLab. If you don't use VLab, you'll never have this problem. But you'll see that every time I load this up, it actually gives me a different VX machine. It's kind of random. I think it's load balance, right? So I got VX4. And if I open it up again, right, I will get I got VX. It opens up on another window. I got VX4 again. And if I open it up again, I get VX4 again. Right? I haven't played around with this since they changed it. Oh my god, I got VX4 again. Maybe they're changing how it works to an extent. I do think there used to be... Okay, I'm just getting VX4 a bunch of times now. But the first time I loaded up VLab for this lecture, I got VX3, which was probably that was like the less loaded server at the time. What's tricky is that when you're on VX3, you are sharing this one server with everyone else in CSE who is on VX3. So let's say there's 1,000 people in CSE on VLab at one given time, and there's 8 servers. That means that there's going to be about 125 people who are sharing that server with you, which means that if there's 125 people who, let's say they're all working on, let's say 10 of them are on 1531, if they all try and use port 3000, they're going to get an error, right? So see how my software works here when I choose 3000. Watch what happens when I try and run the exact same code in another terminal. It will give me an error. It'll say, I'm sorry, but the address is in use, right? Error, address in use is already on this port. 0.0.0.0 is another way of saying like localhost. It's all different. There's a few different ways of saying my computer. So this is what error you might get. So if you are a CSE student using VLab and you get this error and you aren't running it in another terminal, there's a very real chance that there's literally just another CSE student who's used that port you're using, on another machine, on the same VLab machine. They just happen to have been on the course, working on the thing the same time as you, and you just change your port number. You just come up here and be like, all right, I'll just change it to a number. Like, you know, sometimes I used to use the port 6080 a bunch because it's the other course I teach. You know, you could make it anything you want. Like, what's a number I like? I like 2, 6, and 12. Maybe it's a bit low. I like 6 a lot. So 6, 2, 6, 12. There you go. Another port. Keep it between 3000 and 65,000 and it's fine. It doesn't really matter. But that's it. You can run a web server as simple as that. You just spool it up. You define a few what we call these routes or URLs here. Make it any you want, and then you can have it return stuff. And what we're going to be doing in the next lecture is essentially taking that and saying, well, let's go and actually build a server that can be useful, and then tie it into your project a little bit. I think that's probably where we'll stop today. Just to recap on this file again, first line's an import. This is us creating an instance of the server and setting the port that it's going to run on. Oh, there's the link. I was thinking about that. There's a little Twitter post that kind of summarizes these things. Yeah, here you go. Ports between 1 and 1023 are designated as like, don't touch them. Ports between 1024 and 50,000 are registered, meaning that like, you can probably use them, but occasionally there might be some random application that you use that conflicts with them. That's okay. And then ports above that are kind of like fun for development. So in theory, you should probably be using like maybe one of these ports, but it doesn't really matter. As long as it's above 1023, you're fine. So like port 1531 would be fine as well. This is just a quirk that we need to have in Express, which will come up next lecture a bit more. This is the actual running. This is actually defining what the web server can do, what different pages or like URLs it should respond to and give to. And then this one's actually just the running of the server, right? Which Daniel said, does app.listen essentially just endlessly listen for things to correspond to on our app.get stuff? Yeah, exactly. So if you don't run this app.listen line, the server never starts. So this starts the server to start listening for anyone who is calling URLs defined here. That's how that works. Matu says, does every application we install occupy its own port? Only if it's like, well, most applications you install are probably not running a server. They are probably talking to a server, and that server is probably operating on a very standard port. But if you create an application that's running a server, then yeah, it's probably running on its own port, but that wouldn't be very rare. Like very few programs you'd have on the computer would do that unless you're like doing some development stuff like this. So probably not something that you notice day to day very much at all. Do P2p connections still occupy a port? Yeah. Depends how they're connecting. A lot of peer-to-peer happened over UDP, which was a different, I don't know what port UDP was on. Maybe it didn't matter. I don't know a lot about UDP. Probably could have been any port. Maybe. Don't listen to anything I say on this. But yeah, peer-to-peer would still occupy a port. Like a web browser uses ports. Like everything I'm doing on this, everything I'm like when I access YouTube and this slide deck and WebCMS3, everything typically on a web browser happens on port 80 or 443, one of the two. These are in that like those reserved ports, those like first 1,000. So, you know, your web browser is talking to another server on the internet on a particular port. And they're very standard ports. Like for a certain type of application, you can expect it to be on this port. None of that you need to worry about, of course. The port thing is just for background. At the end of the day, all you're going to do is type in a number. It needs to be in the URLs that you access like that. And it works. And if you get a conflict, you just change it. That's about as much as we expect you to understand in this course. Yeah. Sweet. I won't ask for feedback on this lecture yet because we're only halfway through. But next lecture, we will be going through API and keep going.